All right, so welcome back. Yeah, so we were discussing about vectors and scalars, and I gave an example of what vectors are. I talked about vectors and the scalars, and I also gave an example about the scalars. So I don't know if you are going to be seeing the color that I'm using. I don't know which color should I use. Red? Let me try to use red. Are you able to see the pointer on the screen? Because it appears to be very small.
Yes, we're able to see it.
All right, thank you. All right, so I was talking about vectors and scalars. So, and I gave an example of what vectors are and what scalars are. Let me do this. Okay. All right, so I said a scalar quantity is a physical, a scalar quantity is simply just a physical quantity that has magnitude but has no direction. So such quantities, I gave an example of temperature. So the temperature, temperature is one of the scalar quantities that is known. And we also have things like the mass. Mass is also a scalar quantity because it has no direction. And when we talk about vector quantities, we're talking about quantities that have both magnitude and direction. And such quantities are, examples of such quantities are force. Force has direction. That's the reason why some forces, they will show a symbol for direction here on top. Yeah, most of the vectors. Actually, vector is always supposed to be shown in this format. You need to show the direction. And then apart from that, we also have the velocity. Velocity is also a vector quantity. Yeah, so we have all those vector quantities. Let us look at some of these. Yeah, so we have time, mass, and temperature. These are scalar quantities. And then this is a table here that is showing what is a summary of these same quantities. So on the part of scalar quantities, we have distance, we have speed, we have mass, we have energy, density, power. We have all these: area, volume, length, time, temperature, and work. These have no direction. And then when we talk about the vector quantities, we have displacement, we have velocity, weight, acceleration, force, impulse, pressure, momentum, gravity, and drag. So by the end of physics, by the end of the physics course, you will be able to discuss all these. You know what all these mean and their formulas. All right, so let's quickly move on. So let's look at the trig functions and vectors, the relationship between trig functions and vectors. So the most important thing that you need to understand about trigonometry is SOHCAHTOA. So SOHCAHTOA is simply just, when you look at the first three letters here, they symbolize sine, the trig ratio, sine theta. And then this O here represents the opposite. So sine theta is equal to the opposite over the H, which is the hypotenuse. Then CA means cos. The C stands for cos. So it means when we are talking about cos theta, means that we get the adjacent, and the adjacent over the H, which is the hypotenuse. And then when you talk about TOA, which is T, there we have a T, which is standing in for tan theta. And this O stands for the opposite. And then the A there stands for what's this, for the adjacent. Now, one thing you have to understand here is that when we talk about this theta here, the theta is simply just the angle which is there. And then the adjacent side to the angle is simply just this part. And then the hypotenuse is simply the longest side of the triangle. The longest side of the triangle is the one that we take as the hypotenuse. And then the opposite, if theta is here, means that the opposite to the angle is this side there. So this is the one that we take as the opposite. And then the adjacent to the angle is this one. Now imagine that theta is somewhere this side. So if theta is somewhere this side, it means that the adjacent becomes this part, and then the opposite becomes this side, which is this one. So theta can either be this side or where it is there. So what you just need to know is to locate the adjacent and the opposite. All right. So let's quickly move on. So the other thing we need to look at is the Pythagoras theorem. So the Pythagoras theorem is also based on the same triangle that we are just from looking at. You have a triangle. Let me draw a triangle there. So this triangle has theta there, and then it also has the adjacent and the opposite there. It also has the hypotenuse. So when you have, let's say, the opposite is A, and then the hypotenuse is C, then the adjacent is B. The Pythagoras theorem states that when you square the opposite and also square the adjacent, then when you add them, the sum is equal to the square of the hypotenuse. So in terms of A, B, and C, this can be written as A squared plus B squared being equal to what? C squared. So this is what it means. So let us quickly move on and look at other things. So how do you find the resultant of a vector? So how do you calculate the resultant of a vector? So the resultant of a vector is calculated the same way we calculate the resultant of complex numbers. Yeah, so for complex numbers, we would have covered that in mathematics, but I think, yeah, we did part of it, but we're going to cover, I think so. No, not really, we didn't do. I think that's the next thing we're supposed to do. I have to introduce complex numbers and all these, and the other sets of numbers during the lesson. Yeah, so let's quickly discuss how we can find the resultant force of a vector. So if, for instance, you have a vector, you have two vectors, A and vector B. You have vector A and vector B. So if these two vectors are coming from the same origin, or they are called position vectors. So vectors coming from the same origin are called position vectors. And to find the resultant force of position vectors, let me write something like this. So if you have vector A and B there, then you're trying to find the resultant vector R for vector A and B. There are two ways you can do that. Okay, not really two ways, but if the vectors are coming from the same origin, if they are position vectors, you simply just have to follow the direction of vectors. So if the vector is coming from, okay, the resultant vector R is moving from A. If we're moving from A to B, in short, if we're moving from A to B, means that we're going to move in this direction. and then go towards that direction. So we're moving against the direction of A. A is facing this side. The direction of A is facing this side. Since we're moving against the direction of A, it means that our R is going to be equal to, so the first thing we're going to have is A in the negative. So we're going to have negative A, and then B, positive B. We're moving in the direction of B. So we're moving like this. So we move the negative side of A and then the positive of B. So the resultant vector R is therefore B minus A. That is if the vectors are coming from the same origin. Now, what if, or how can we use the, how can we use how can we use trig to find the resultant vector? So if you've been given the, it's just that I don't have enough space here, but I'll manage to write something. So if you've been given anything, if you've been given, let's say, vectors that are in a plane, like in the XY plane, you have maybe this vector, and you have vector A, then you also have vector B. You have vector B. Okay, let me write one this side. So you have vector A in that direction and vector B in this direction. So what you need to do is to find the scalar quantities of these two vectors, the scalar quantities of these two vectors. What do I mean? We're going to find the trigonometric components, the scalar components rather, of these two vectors. So what that means is that we're going to find this A in the X. We also have to find the same A, the magnitude of A in the Y. So A in the X and A in the Y. We also find the magnitude of B in the X and B in the Y. So B in the X and B in the Y. You find these components. Then after finding the components, the next thing that you need to do is to find the summation of these forces in the X. You also find the summation of these forces in the Y. So in the X, we have AX and BX. So we have AX and BX, but B is facing towards the negative side of the X-axis. So we say negative B in the X. And then in the Y, we have A facing towards the positive Y-axis, and B is also facing towards the positive Y-axis. So all these are positives. So after finding F in the X and F in the Y, you find the solutions this side. So you find F in the X, you also find F in the Y. Now to find the resultant force will therefore be given by the magnitude, rather the square root of the force in the X squared plus the force in the Y squared. This is how you find the resultant force. And how do you find the direction of these two vectors, or I mean the direction of the resultant force vector? So the direction is simply given by theta is equal to the tan inverse of the force in the Y, over the force in the X. So this is how you find the direction of the resultant vector. Okay, let's quickly move on. Okay, I've explained this. This is how you find the direction. So these things are simple. They are simple and straightforward. So the rule of quadrants. Okay. So the rule of quadrants, this is also very simple. What you just need to know about quadrants is that all trig ratios in the first quadrant, here, all trigonometrical ratios, meaning sine, theta, cos theta, and tan theta, are all positive. So all positive trig ratios are, they fall under the first quadrant. And then in the second quadrant, only sine theta is positive. In the third quadrant, only tan theta is positive. In the fourth quadrant, only cos theta is positive. And how do you master this? Okay, this one is the first quadrant, this one is the second quadrant, then this one is the, oh, sorry. This one is the third quadrant, this one is the fourth quadrant. So now how do you find these, or how do you master these quadrants? So if you want, you can just take it as, or you can take it as, let me do this. This is how you master them. So all students take calculus. All students take calculus. Or if you want, you can take it the opposite way. You start from A, C, T, S. So A, C, T, S, meaning this is Acts from the Bible. So if you want, you can master Acts. That is, if you start from this side, going this other side. Or if you want to be going in the normal way, which is the first quadrant, the second quadrant, the third quadrant, the fourth quadrant. If you want to follow this direction, meaning you have to take that other mnemonic word sentence which says all students take coffee, or all students take calculus. All right. So let's move on. It's as simple as that. We're going to see how we're going to be applying these things to solve questions. Okay, I think, is this a question? Okay, so vector components, I've talked about this. So I've already talked about this. Let me just run through it. So vector components, we have a vector with the resultant, we have the resultant vector R. So how do you find this R in the X and R in the Y? We know to say this can be drawn as a triangle, having the angle theta there. And to find this R in the X, so this R in the X, we know that this is the adjacent to this theta, and this is the opposite to the theta. We use the same SOHCAHTOA. So SOHCAHTOA is applicable and it's very important. So we use the same SOHCAHTOA. So in the X, what is the component, the X component of this vector R is, the X component of this vector R is simply just the adjacent to the theta. So sometimes if the theta is this side, the X component is going to be the opposite. So it's not always that the X component is the adjacent. Sometimes it can be the opposite if the theta is located there. So what this means is that in this case, in this given example here, we have the X component of this vector R being the adjacent, and what we have been given, this R is the hypotenuse. So which one deals with the hypotenuse and the adjacent? The adjacent and the hypotenuse is found under K, which is cos. So meaning cos of theta is going to be equal to what? The adjacent, which is the R in the X, adjacent over the hypotenuse, which is just the same R, which is the vector R. So now we want to make R in the X the subject of the formula. So we cross multiply. So the R, which is the X component of this vector R, is equal to, when we cross multiply, R times cos theta is going to give us R cos theta. So this is where they got this R cos theta. The same applies to the Y component. So the Y component is simply the opposite to this theta. So opposite and hypotenuse there, we use sine theta. So we know to say sine theta is equal to, so the opposite to the opposite is the one that we're trying to look for, which is the R in the Y. So the opposite is simply just the r in the y. So we have r in the y over the opposite is simply just r in the y, and then the hypotenuse is simply just r there, which is what we're going to put there, because we know to say sine theta is opposite over the hypotenuse. And then to find r in the y, we cross multiply. Then when we cross multiply there, we're going to have r times sine theta. It's going to be r sine theta. And this is what you're going to get as, your vector component in the y. Okay, so we proceed. Let's look at this example. So we have been given this force. Okay, in the figure below, the magnitude of the resultant vector is 40 newtons. Determine the values of x and y components. So how do you determine the values? So we've been given to say this 40, this is our what? Our resultant, or let me say our force that has been given is what? 40 newtons. So now, how do we find the x and y components? So we have to make a triangle there, and then we have two sides, which is the opposite this side and the adjacent to the angle. So to find the components, we need to know to say here, this is the adjacent, but aside it being the adjacent, this is the x component of that force. So we have the force in the x, we also have the force in the y. So the force in the x is the adjacent. So we have the hypotenuse and the adjacent. And then from SOHCAHTOA, we know to say the one that has the adjacent and the hypotenuse is cos. So we are going to say cos 30 is equal to the adjacent. So the adjacent is what? Is f of x, I mean fx, or the x component of the force. And the hypotenuse is what? The hypotenuse that have been given is the longest side there is 40. So the force in the x is simply just going to be 40 times cos 30. So force in the x will therefore be cos 30 according to the spatial angles. But this one you can use a calculator because it's physics. But if it's mathematics, you use the spatial angle. The value for cos 30 in spatial angles is simply just the root of 3/2. Then you multiply it by 40. But if you have a calculator, you can simply just use a calculator. This one is straightforward. And this is going to give you 20√3. Or if you use a calculator, the solution that you're going to get is 34.6. So the x component of this force is 34.6. Okay, so let us see how we can find the, of course, we don't have to forget to put newtons this side, even this side. Okay, let us also find the y component. So the y component is the opposite to the angle. So the opposite to the angle is fy. So which one deals with the opposite and the hypotenuse? So the opposite and the hypotenuse is sine. Is sine. So we know that sine 30 degrees is now equal to, the opposite is f in the y, and then the hypotenuse is what? Is 40 newtons. So the hypotenuse is 40 newtons. So we cross multiply there to get the force, the y component of this force. So 30 times times sine 30, rather 40 times sine 30. So we have 40 times sine 30. So the y component is therefore going to be equal to, so 40 times sine 30, according to the spatial angles, is simply just 1/2. And then the y component of this force is simply just going to be 20 newtons. All right, so this is how simple it is. Do you have any questions before I can proceed to the next one?
Yes.
Okay.
So the longest, so it's simply the longest part of a shape is the what do you call
The
it?
hypotenuse.
The hypotenuse.
Yes, the longest side is the hypotenuse. And
Okay.
then the one which is just right below the angle is the adjacent. And then the one which is opposite to the angle is the one that we call the opposite. That's why it's called
Oh,
opposite. Yes.
all right.
All right, we proceed. So if you have, okay, let me give you, in this remaining 2 minutes, let me give you some practical examples. The one who asked me a question, I want you to answer these examples I'm giving you. So you should be responding. So I'll draw a triangle here because it's very important. That's where a lot of people miss it. So we can't move without you understanding this properly. If we move, then you will not know anything. So we have this triangle. And I have my angle theta there. This is my 90 degrees, which we have A, B, and okay, let me write them like this. We have C, A, B. Which one is the opposite here?
The
B.
opposite is B.
Yes, the opposite is B.
Opposite,
Then which one is the
opposite to
hypotenuse?
the C.
Is C.
Okay. What if we have this triangle? Okay. Theta. Which one is the adjacent?
The adjacent is
A.
Yes, the adjacent is A because it's this side. The theta is here. And then the opposite is B. The hypotenuse is the longest side. All right, so the link is ending right now. So you join using the same link so that we finish up the remaining part.
okay.